is Reis Zandier, and I am a senior chemical engineering student at Youngstown State University. I would like to begin today by thanking you for joining me, whether that is my family in the living room or you virtually watching. Today I'm going to be discussing the detection of cocaine by physically functionalized carbon nanotube sensors. Throughout this presentation, I'm going to be discussing the experimental methodology, the discussion results, and then the conclusions that I have made. I have been working in the materials science lab as a research assistant for the past 2.5 years at YSU under Professor Dr. Cortez. In the materials science lab at Youngstown State University, our main focus is additive manufacturing, which is also known as 3D printing. Throughout 3D printing, we have mainly focused on the production of sensors and the fact that the sensors can now be produced as flexible sensors. Over the past 2 years, I have worked with detecting solids, liquids, gases, and other hazardous materials. I have worked with both hazardous and then also explosives. Some things that I've worked with in the past include NOx gas, carbon monoxide gas, cocaine as a solid, and then also cocaine in H2O. The objective of this project was to detect cocaine by a flexible 3D printed sensor. The reason that I chose to do cocaine in water rather than cocaine in the solid state is because of the original difficulty detecting the cocaine in the solid state. And I think that this was because of the fact of the particle size of the cocaine. I believe that it was too small compared to the particles of the carbon nanotubes. To give you a little bit of background about carbon nanotubes in general, so carbon nanotubes are really just a small scale version of carbon. The reason that they are used for detecting is because of their detection in electrochemical properties. So the actual structure of carbon nanotubes work really well in detection with these other functionalized groups. So a picture of carbon nanotubes up close is seen here. And the type of carbon nanotubes that I used in my research was single wall COOH functionalized. And the reason I use this is because single wall compared to multi-wall can detect a lot more precise of detection rather than the multi-wall. Now to go into the experimental methodology. So to begin, I started by making solutions and then I prepared the sensors, which were then used for data collection and testing with different solutions. This table here will give you a better depiction of the type of sensors that I prepared. So to begin, I created 3 base solutions, one containing carbon nanotubes in water, the second containing epinephrine, and then the third containing no epinephrine. So sensors 1 and 3 contained epinephrine, while 2 and 4 contained no epinephrine. 1A versus 1B is comparing the testing. So all of the sensors with A were used with pure water, while all the sensors with B were tested with cocaine in water. So A was almost used as a base sample so that we had something to compare with. And what I concluded from my testing was that epinephrine was a better binding agent compared to no epinephrine. So I continued on with epinephrine in my testing, and that's the data that you'll see in the next couple of slides. Oh, and then also the difference between 1 and 2, or 1 and 3 and 2 and 4 is the difference in concentrations. So while 1 and 2 are 1-to-1 concentrations, 3 and 4 are 2-to-1, so I increased the concentration of the carbon nanotubes compared to the epinephrine. As far as the preparation of the sensors went, I first started by pipetting 20 microliters of each solution onto the carbon nanotubes. As you can see here, these are the CNTs, the little black dots. And then these electrodes were baked in an oven for 60 minutes on 60 degrees Celsius. And this gave them a chance to cure to make sure that we weren't losing any carbon nanotubes throughout testing, to avoid flaking and to avoid some other things that could occur. So this is the setup that I used for testing. Here you will see a power source, and I used 5 volts of power throughout the circuit. I worked with another I worked with an electrical engineer who helped me to create this circuit, because that's obviously not my forte. And the data acquisition system can be showed here, and that was all connected to my laptop, which allowed me to obtain these results as I was testing. So the electrode here is also right here in the circuit, so that actually just replaced a resistor, and by replacing this resistor here with this, we had another comparison of the resistance. So overall, the main thing that I was trying to collect was resistance. So now on to the results and discussion from this testing. As you can see, and as you can imagine, a lot of time and effort went into this data collection, and then also into analyzing and compiling in order to produce these graphs. So what you can see on the left here is 3 different trials with each sensor. So these 3 lines here are identical sensors tested with an identical solution of water. So this sensor 1A was 1-to-1 epinephrine tested with just water, while this sensor here was 1-to-1 epinephrine tested with cocaine in water. So these 3 trials and these 3 trials were averaged together in order to compare right here. So the main thing that we want to look at when we're looking at this graph is the fact that the red line is tested with cocaine in water, while the blue line is tested with pure water. So we use the blue line as a base case compared to the red line, which is the cocaine. So as you can see, there's a difference because there's less of a change with the cocaine in water than just the plain water. And like I said, this was the 1-to-1 sensor. And now here we have the 2-to-1 sensor. So the 2 is describing the CNTs. So I increased the concentration of carbon nanotubes in order to produce this graph. Again, these were averaged like before. I just didn't show each average again. But the takeaway from here is the fact that this red line and this blue line are a lot closer together. And the reason for this is because by increasing the carbon nanotubes, you're increasing the functionalized groups. So with that, there's going to be less of a difference in the reaction. So now I would just like to talk about the past 2 slides in comparison. So this is comparing the 1-to-1 compared to the 2-to-1 ratio. And like I said before, there's less change in the 2-to-1 than there is to the 1-to-1. But what we really like to see here is the fact that there is still a change in all 4 concentrations in all 4 tests. It's just the fact that there was less of a change with the cocaine in water rather than the plain water. So the red line is below the blue line in both cases. So in conclusion, yes, there was detection of cocaine. There is a difference in cocaine and water compared to just water. There's also a difference in concentration from 1-to-1 and 2-to-1 using epinephrine. I also concluded that epinephrine is a better agent than norepinephrine, so I focused on using epinephrine. And then also the fact that cocaine was more easily detected in its liquid form in water. In future work, we're going to be trying to detect solid cocaine using different forms of CNTs and trying to find a better combination. But with the results that I have obtained here, the future work will include moving the blue electrodes that I was using onto a 3D printed platform of an electrode. And the reason for that is because it will actually be used as a patch that people can wear in the Department of Defense, which is who this project is for. So within these patches, these 3D printed patches, there will also be electronics throughout and an LED light which will be showing the detection rather than these graphs and explaining it each time. Somebody will be able to wear the patch, see the blinking light, and know that there was detection of cocaine in this instance. But in previous work, in my last year's project, I was actually able to detect nitric gas. And the way that I was able to do this, I'm going to show on a video. Cut for now. Cut. In this video, you will see a reaction that took place between nitric acid on a piece of copper. When the nitric acid reacts with the copper, a hazardous gas is released. Nitrous oxide will start to diffuse throughout this apparatus, and the carbon nanotubes right here will sensor that the hazardous gas is in its place, and then the LED light will start to blink. This was actually part of my junior research project last year. So this was 20 microliters of nitric acid added to copper. And as you can see, there's going to be a little bit of visible gas down here. And then as a result, the LED light will blink. So this is just a little picture into where we're going with the cocaine detection, the cocaine sensors. And this coin right here is actually 3D printed. So with the use of additive manufacturing, you can turn that off. Thank you. With the use of additive manufacturing, there's actually a lot of great things happening in the world today. At YSU specifically, we have one of each of the 7 types of 3D printers, which is very rare for institutions around the world. And in this crisis time of the pandemic and COVID-19, people have actually been able to 3D print different types of masks and proper PPE for nurses, doctors, and people in these facilities. So if you're watching and you stay tuned, Juggerbot 3D is actually a company that we work with in our lab that's downtown Youngstown, and they just sent out a shipment of 3D printed masks that go over the doctors' faces. So in times of crisis, we're able to use technology and these advancements to our advantage. So I just want to say thank you for watching today, and I hope you all stay healthy and safe, and I hope you learned something.